Okay, so today is the 13th of February 2022. We're going to be doing a walkthrough on the FBX migration from Unity into Houdini, where we're looking to optimize the assets so that they can actually be re-imported back into Unity, but in an optimized fashion. All right, let's get into it. Um, right. A lot of changes on this specific asset. I'll give you a walkthrough of what it's looking like at the moment. But essentially, normally when you have your assets set up in Unity, it's like FBX prefab, FPS prefab. Whereas with this, it's one FBX with all the meshes in a single file. Nothing wrong with that, right? It just means that the pivot point, you need to now find that pivot point for that asset and then kind of reverse engineer it when you're in Houdini. So let's see if we can look on this setup here. So essentially, each one of these is just another area. So cargo bay, if I go into cargo bay, these here are the prefabs. And if I dive into source, then I have a single file. Nothing wrong with that again. And then when you break those down, they're all, if you look here, all of these are pointing at the same file. So that workflow for me is slightly new because again, I'm used to mesh prefab, right? Okay, so that was not apparent that that was the case until I actually got um, into Unity. Okay, so here's one of the issues. So when I click on each one of these, the pivot point is in the center of the object. Well, it appears to be varying places here, right? Um, but that's only because that here has depth. So let's see if we can highlight that one here. So that one looks like it has depth, sorry, right? So it's only just that mesh, but it's centered to the actual geometry, which is fantastic. And so you're thinking, I'll just get that into Houdini and check the center point. Pivot. Oh my God, not so much. We're gonna be touching on that workflow because the previous workflow had scripts for that, had scripts to get them in, but I know that they had some issues with, or not even issues. It was just that some of the assets were scaled and some weren't. Whereas if you check the transformation on this asset here, for example, let's see if I can get this into. So there's a scale. So the scaling is just 111, and that's for all the assets. All the assets have just 111 for their scaling. So then I was like, I don't want to get into all the mathematics for the prefabs and for the scale, and oh my gosh. So that's where I left the previous asset, and then I spent a lot of time actually bringing that into Houdini, and then getting that optimized and everything, only to not realize when I get back into Unity, each mesh could have like anywhere from two to like five, six, seven materials on a single mesh. That's six or seven draw calls per mesh. That's a lot of work, right? So, and it's not even the work, it's just when you get to the device, now you have to render out that material against that mesh six or seven times. So that overhead then means that you're not hitting the optimization target. So on studying this asset, one, it looks good, and then two, it's like a single mesh to material mapping, right? One to one. So so far so good. Get everything into Houdini, and then we have to go through the other steps. So we started this exercise maybe about a week ago, because the asset was just released, and I was like, that's fantastic. I'll take that one. And I just finished like light probe setup and started baking lighting against the previous set of assets. So it's like the timing was perfect, impeccable, right? Some kind of mystic, you know, heaven earth type scenario. But anyways, let's focus on this now. Right. So we talked through the prefab configuration and the issue with the FBX having all of the different assets in a single FBX file, right? So the next thing I wanted to kind of give a walkthrough on is the prefab exporter, right? So essentially, we're walking through the the different folders. So each folder is like a representation of a level, and which is good, right? So from a grouping mechanism, that's quite helpful. So then we then change the data shape for the prefab for the JSON file, which is going to be housing the information that I'm going to then interrogate in Houdini. So this is just to kind of give you an idea as to what that looks like. So you have the prefab file name, and then you have the prefabs in an array, right? Um, and so it's just actually capturing this information. So it's not scene specific. So a lot of this is kind of zeroed out. It's just kind of how that was kind of set up when I started looking at this maybe like 2, 3 years ago, right? So we're still storing the same information, but I'll finish kind of showing you what we've got here. So I'll just keep collapsing these until uh, they're all showing on the screen. Again, you walk away from something like this and don't look on it for 2 years. Oh my God. Yeah, you have to resurrect all that knowledge again. So, yeah, just to give you an idea. So, there you have it, right? Uh, each file, multiple prefabs. It could be like 20 or 30 inside there, and they're just reusing them to kind of build back up the level. So, this is generated with some editor scripts. So, at the moment, this is how the configuration is set up. And so I have a section here and I say generate prefab JSON file, right? And there's no reason for this to change, but that's how it is at the moment. And that will then kick off a script in here. So this is version 1 of the parameter extractor, and then this is version 2. So it's like, I mean, I'll just do a quick kind of scroll. This file was copied from version 1, and I just kind of hid like some of these classes because, how can I say? The other file have the class reference, and I didn't want to split them out into multiple files. It was just kind of easy to just jump in there and get going. I didn't know whether or not I'd be sticking with the whole process. So it was just like, forget the Scrum meetings and the Scrum email. I'm just gonna just get at this. So again, we started last Tuesday, and this is where we are. So I'm just gonna quickly scroll through this. I'm not going to talk it through. It might be something that I want to kind of have a quick ready reference, a year or two from now, and that's why we're generating this video here. So here it's saying this is a recursive loop, and we're just going through and capturing the information we want, and mapping that back to the structure that's going to be saved to the JSON file. So just standard serialized, deserialized configuration, right? So there we have, and then we load the prefab, we capture the data. So again, nothing too sophisticated. Uh, it's just what it is. And I'm tweaking code that I coded years ago. So yeah, as long as it works, just the surgical strikes that you need to make so that you can actually carry on with the exercise that you're doing, right? So I can hide that. So that's the editor script. And then we have a scene builder one is, no, this is something else. Right. So we've talked through high-level Unity. I'm now going to go over to Houdini. Okay, so one of the things that I had as an issue was trying to remember how I did the import on all the assets that I was previously working with, right? Um, so let's go ahead and just give you a high level idea. So this, the right hand side here, this has been set up to generate those assets and also generate the layout. So I have a layout JSON. So we just talked about the prefab JSON file, but there's one specific for the levels as well. Okay, so rather than talking at you, so we have the JSON loader here. So this is going to generate like point instances. So let's see. So about 2, 3 years ago when I started this exercise, the focus was primarily on using instances. So this Houdini engine principle back in like, 2019, 2020 was something relatively new. Um, and so it was like instancing was the way to go, i.e. point instances. So you put the attributes with the name of the asset and the material, and then send that through Houdini engine, and then that would actually end up um, pointing at the prefab in Unity, and it would orient it with the normals and everything else, right? So this is what that script does. Um, and then we just blast the levels that we don't want to see, and then pass it through a loop. And you're welcome to go through this at your own pace when you're ready, right? And then this file, this is all the referencing, the file references using the file sup, and then I'd be in code pointing at one of these null nodes here, right? So if I was to look on that, and there's that one, and there's that one, and there's that one, right? You get the principle. Okay, so I spent maybe like a day looking for the code that I used to generate this, and then I couldn't find the code. Right? It's like I was so gutted. It's not that it's complicated to code, but again, it was like if you already coded it, you don't want to code it again, right? So then as I literally just, I went to sleep, and I got up in the morning. I was like, wait, I don't need that code. I was using a different technique, right? So it's almost like that was like a bit of trial and error, right? So let's see if we can demonstrate what we got here. So this is for the zones, right? And this is all of this is kind of auto-generated from the JSON, right? And then we get something like this, and then each one of these, so this has props, this has floors, and if I just sort that, yeah, I mean, it's brilliant, and we're using Python to do that, right? So if I was to go up a level, and this is zone 1, so if I was to see what that looks like, hopefully that shouldn't take too long to cook. So it's just processing now. Yeah. And it's like, I mean, even me, I'm impressed. It's like, so why don't you want to work with this asset? And then if I pull out, you'll see that some areas are like kind of what you would expect. It looks right. And then some areas, like the floor is supposed to be down here, but these meshes are all with 111 in the scale, sorry. Um, Whereas some of these, like they would have been scaled, and so it's like that's why it looks kind of disjointed. It's placed in the right location, but it was like, yeah, that's going to be more work. And at the time, I didn't want to be spending too much energy on trying to reverse engineer it. It was just more, okay, let me just pick the parts of the assets that I like and stick with that workflow, right? So not too bad, not too bad, right? So let's just I'm just gonna step out of this for a second, and I'll just randomly pick another area just to. I mean, even now I'm looking. I was like, hey, why don't you still run with this? This looks good, right? Okay, so we'll just let that cook. So I had all these questions last week. Um, it's like this looks excellent. Why would I want to move away from it? And it was like, mm-mm, I need to be focused. Like somebody's already spent a lot of time putting this asset together, and why am I going to be spending energy trying to get everything to line up like this, right? And so I did manage to come up with a great solution, as you've seen in the other videos. It's just more, um, how can I say? I mean, it was exploration, R&D. Um, that was kind of like the first time that the tool, I mean, like I said, 2019, 2020, Houdini engine was like becoming a bit more popular, a bit more stable as well, right? So like now if you pick it up, it's like it's got some years behind it. But I mean, even this asset here, it's supposed to be oriented differently. And we're talking about thousands of assets, or at least no, hundreds of assets, but in terms of coding and you're trying to do something procedurally as well. So it's like, I don't know if I want to be putting in all that extra effort on something that's supposed to just work. Anyways, let's head back to it. Okay, so this is where I left off about a year and a half, no, definitely 2 years, over 2 years ago. And so the idea here was, how do I now get these FBX files split up and then get each one of the assets down to the origin with a pivot point in the center? And that's what we're going to kind of walk through now. So I only just got that working in the last hour. So some of the code, it's just comments and it needs cleaning up. So yeah, I'll be spending some time doing that, but it's like I just need to document this while it's fresh in the head, as opposed to having to kind of think it through too heavily later on. So this is the script that's built up to load and create the prefab points. Now, I don't really care about the points information right now, but I'll scroll right down to the bottom because it's just how the file kicks off. So we load the JSON file, we start a loop, and then remember we've got everything segmented by level, right? So we come in, we load up some of the key information. There's nothing here that's too sophisticated, but then we call into that function. So I'll scroll right back up to the top. And yeah, we just start picking up the information that we want. And then what I'm doing in this instance here is I need a file reference to get the file off disk. And so if I just go back to the JSON file, if I can find that. So there's a JSON file. And so we load the prefab file, right? So we get that full reference there. And then now we start working through the actual loop itself, right? And so the first thing we do is we split. So the split node allows you to get by name the asset you're after. So let's go back here. And so we have this here, but this is, so it says crystals V101. So that's the mesh. And that's what we actually use in Houdini as a group to say, okay, fine, isolate this section off the FBX file, and then that we have two points, two outputs from that node, and we just grab the first one, which is like doing a blast at the end of the day to get rid of the others, right? So anyways, we carry on. So then we do the split node, and then what I have here is a bound, and the bound is just like a box that encompasses the extents for the geometry that you're currently working with. And we use that later on. So it's not a part of the core network, it's just a reference node, and then we call at it from Python to be able to say, okay, fine, we want to get this information from this. Now, there is an extract centroid, but I'm automating things and want to set parameters on it. And the parameters, even though I had the right parameters, it was like, no, I don't want that string that you're giving me to tell me it's supposed to be a detailed parameter, right? And things like that. I was like, no, there's another way. So if I'm in code, I should just stay in code land, right? And then that's what I end up doing. So then we create an attribute wrangle node, and we essentially we want to get some information from the file itself. Now, During the initial phases, I was seeing some coordinate information, FBX translation. Let me show you what that looks like. So I'll just close that down for a second. Now this is where the end result is going to be ending up. This is the container that's going to be housing the prefab, right? So I'll just dive into that. And then these are all the networks that have, or subnets that have been set up. And so I'll dive into this one. And then this is how we've got it configured. So it's generating a file node, then it does a split, right? Like I mentioned earlier, there are two outputs. Then from there, we get this bounds, right? But it's not a part of the main network. It's so that we have something to refer to. Then from there, this is what I mean when I mention that we need to get some reference. So I want to have this as a detail. So we're making a detail here called FBX translation. So what's FBX translation? So I'm just going to quickly reference this here. And we'll go over to the geometry node. And so within the FBX, we have this information, right? And so I spent a good portion of last week thinking this is going to be exactly what I'm after, and it's going to save the world. And in the end, it has been quite helpful, but we had a few pain points. I mean, obviously, you're learning about the FBX workflow, and the goal is about level design and setting up levels. It's not about the FBX, but it's part of the pipeline, so you need to be able to work with it, right? So, yeah, that's what the data looks like at file level. Point data, a lot of vectors. We have the normal information for the vectors themselves. We have the primitives, and it's telling us what material reference it has. And then we are creating with this particular script here the this vector information, which is just a copy of the information that was on the point. It was just reading the points at Python level in an automation script. It seemed like more work than it was worth. It was like, if this is going to take more than a day, I don't want to do it like that. I want to find a better way to do it, right? So, anyways, then we move on down. And then within this edit node, we're setting the pivot point. So I perceive this was like, part of the R&D is like, how do I get this pivot point set up? And I was able to get this set up by essentially injecting this data from the FBX translation, right? So how is that being done? Well, with Python, I'm automating a Python node that's automating the retrieval of that attribute for that vector and then writing it back to the edit node. Fun, right? All right, so yeah, that was like, I was interesting, and I was dealing with the kids at the same time, and they're like, 6,000 kilometers away. So wow, so yeah, I can multitask. I learned that, right? So this is what we have. um, and so all of this is automated, so I haven't had to hand type any of this. It's in a loop, it's looking at attributes, and it's generating everything for us. So what I ended up doing in the end is skipping this FBX translation and looking at the bounds information. So we talked about the bounds node earlier, and generating the centroid, and then setting the centroid to the pivot data, right? So you're looking at this here now. Let's see if I can make that make sense. So here we are. Here's the edit node. Here's the pivot translation. These numeric values are being set by the following node, which is a Python node, which is reading the centroid from the bounds and putting it into the parameters for the edit node. It works. Don't question it. That's how you do it, right? And hence why I'm making this video now, because I don't want to do this again. Okay, so we've talked through the Python node, and so the next thing on from there, we have a null node, and then we have another Python node. And that Python node here is kind of doing almost the same thing. So essentially, we have another transformation, and just to show you what that looks like, we have another set of configurations for the pivot translate, right? Which is taking in that similar data, but the translate for that data is the inverse of the pivot values. Now, if you don't have a book to read to figure that out, oh my gosh, that was painful, but you know, a couple of days we managed to get that going, right? And so that's what that looks like right now. So if you look on it, that's negative, positive, that's positive, that's negative, and that's negative, and that's positive. So it's just the inverse. Now, there's possibly some kind of routine that would have done some kind of matrix multiplication to be able to do that. Um, that's not the target. The target is just automating this into the pipeline, right? So that's why I skipped it. Now this node network, which is replicated through all the prefab networks, is essentially identical. It's just a script, right? But that's what that looks like. And then we finish off with an output node here. So we talked through that. Now let me visualize what we've got here. So um, that's a scene. And so if I look at the file itself, just change this. So here's all the meshes that come with that specific level, right? And so that was the issue. I mean, at least when I was initially visualizing it, it was like, well, how am I going to get all these prefabs initialized separately so I can then rebuild the level, right? um, in an automated manner. So if this was something that you were going to do manually, you could just jump in Maya and it wouldn't be no problem, right? And a matter of fact, Maya would have it set up with the pivot points for you just by clicking. So you just click on the file, you click on the actual prefab, and voila, you then have your pivot point information. However, here you have to go and calculate everything yourself, which I won't say no. It wasn't fun. It was a lot of work, a lot of coffee, a lot of late nights. But yeah, we managed to get that going. So let's now see if I can show you that in Maya. So here we have a similar file in Maya, and again, if I click on this pivot point straight away. So if you're doing something like this manually, in another tool, it's just like no problem, right? But obviously you're doing it manually. So if you have hundreds of assets, you got your work cut out for you, right? So yeah, the idea of working with Houdini, and you could do this with Maya as well, but the pipeline has already been established in Houdini, the one that I'm building, and so it's like you got to stick with it. So sometime when you come to do your R&D, there's a bit of pain points, but you know that's why you stick with it. You know, you got to get the job done. Okay, so that's the starting point. That's what that looks like right now. And the whole idea here is we want to isolate just an individual part of this asset selection here. And then there you go, right? Now, where is that in comparison? The origin is here. This is where the asset is actually, right? So let me just isolate that, and yeah. So this is where it starts off, but this is origin. So we want to get this down to origin. Let's scroll in here, right? And keep going. So the next thing that we do, and again, remember this is automated, is we grab that translation information and write it. So we take it from the point because it's set up in the FBX at point level, and then we're going to write that over here as a detail node. So there's a single variable waiting for us, right? And then so that's the wrangle. The next step is just the creation of this node. But when it's created, it doesn't have the pivot translate. The pivot translate, it has been automated to get that from the bounds, right? which is it's not a core part of the network, but it's needed for that purpose. Gets the centroid off that, so that calculation takes place, and then we then assign that back to the edit node, right? Carrying on, then we go to this Python node here. We calculate and we do something similar to another edit node. I think that could have been potentially automated twice, or no, we're on the wrong node. Right. So the next thing here, we have another translate node in this workflow, and this one we write to the translation information, the actual position data, and we also write to the pivot translate. So I'll just kind of highlight that. So there's a centroid information coming through. We write the negative of the centroid calculations to the transform on the translation X, Y, and Z. And then for the pivot values, we just take the whatever value is there, we take that in. And so let's go back over here. And so before we execute this one here, so if I go up, we're currently on that transform, but by when we click on this one down here, now we're back at the origin, right, with the pivot point there for us. So just to kind of emphasize why we had to go through all those steps. Now, if we look on these values here, and look on these values here, this is the variable that's coming from the points. So looking at the point data, each point is using the same data. If you look on the data here, this matches up with that point information. And then if you look on these values here, this is the inverse of that. So everything, I could have just, taken that value directly from the point data and just had one translation step if I think about it now. But you almost had to go through the pain points to get back to this location, right? In terms of all those steps. So could I potentially have done this in a slightly more simplified fashion? Possibly, but I've already done it, and I don't think I'm going to spend any more energy, trying to build this out any further. So yeah, we just did a deep dive on why the network was configured like that, and so just to kind of highlight that there, by clicking on the Python node, that kicks it off, right? So we'll just give that a couple of seconds to finish. Um, we have a bit of fun with that. So, I mean, you then have to go through and delete everything and then rebuild it up, right? So, yeah, just give that a couple of seconds. That'll finish, and then I'll continue to walk through with the actual scripts itself. I mean, one of the things that is also quite key here is the amount of memory that's being utilized during this execution. So that's 98% of memory being utilized right now, and I don't want that to crash, so I'm going to close down Maya, free up some memory, and I'll close down Visual Studio, and I'll also close down, I will leave Unity for the time being just in case I wanted to kind of talk through some other issues, or discuss the design or something like that. Right, okay, so that's now complete. And so I just come back in and Alt E to isolate Python window, and we'll continue. So the same node, so this script is what generated all of that, right? So the attribute node, the edit node, the Python script that's going to be executed to update the edit node, a null node creation, not really needed, another transform node, and then some workflow here. A lot of this has been commented out, as you're going, you're coding and like, no, I don't need that, and then you hide that and that sort of thing, right? but we just want to focus on the bits that were needed. And then here you go. So one of the important things that I must note here is when we come to inserting this centroid function, this is sitting inside two ticks, right? Um, oh my gosh. So this line here, which is I'm essentially writing a comment to the script that I want to execute. And if I take that out, what happened was while executing, I noticed that for the DX, for the centroid, it would essentially just delete that code, like for no reason at all. It makes absolutely no sense at all. It's a string. There is no logical reason for that code to just disappear. So I'm looking in this code like I'm either going to get in touch with the company to find out why on earth that would happen, which would take time, or what I didn't even know I was going to do. And mysteriously, again, get some whispers, and it's like copy that code, put it in the line above, and comment it out. It looks identical, and so whatever its algorithm has got to strip it out, it can feed off the commented version of the code, and leave this part of the code to execute. That worked. That none of that made any sense. You shouldn't have to do that at all, but managed to get that going. So I'm really chuffed about that, right? So, anyways, so it's not just the centroid function that's here, it's the centroid inside of these ticks, because it's not Python that's going to be doing the calculation. It could be H script or some Python native, Houdini native code, right? So we carry on. So that's the only thing that's kind of funky about that script there. We assign these variables and then set the translation position data with the negated values and the positive values going into the transform. And then everything else is just the standard workflow as we talked about thus far. So I've shown you what the actual geometry looks like, the fact that we get it back to the origin and the pivot point is being set. Super chuffed. And so the next thing now is to, well, get the actual levels to feed off that data. So I haven't done that bit yet, but I was like, I might not look on this code again for, another couple of months, years, and to deep dive on that and going through those pain points for a week, you want to make a note of what was what, as opposed to trying to come back to it and hate yourself for not documenting how you actually managed to get there. So yeah, the next bit to actually look on is going to be this section here that goes through and builds up the point data for the levels. And so just to see if I can kind of step through this quite quickly. Again, I've not looked on this in like 2 or 3 years, but this is the configuration. And so when I go ahead and click here and then highlight this, it's going to go ahead and attempt to set up the point data, the point information. This is looking at the old version, so we need to update it to look at the new version, but that's going to be the next video. So again, I hope that was helpful. I know I'm definitely going to find that helpful if I ever need to come back to this. So I'm going to leave that there for now. Again, thanks for watching, and I'll